We're here this morning in Guadalupe County on Elm Creek Road. The Alamo Area Council of Governments, AACOG, and HDR Engineering out of San Antonio are working with Guadalupe County Road and Bridge Administration in the construction or road repair of this particular project for Guadalupe County. The road repair process that we have brought down to Guadalupe County is called mechanical concrete. It's out of West Virginia. And we're here to look at it for the first time in Texas to see if the application will work on the county roads in Texas that have been damaged by the increased traffic and heavy loaded truck traffic due to the oil and gas production increase in South Texas. I'm going to turn it over to Jeff Lebens-Huff with HDR, and we'll explain a little bit on the technical aspects of the mechanical concrete process.
The key to this system is the simplicity of the system. Containment of the base material is the key to how this thing works. Because the tires contain the gravel when loading is applied to them, you can basically get 18 to 20 to 24 inches worth of load support in an 8-inch section. Because when the loading's applied, there's no place for the gravel to move. So the loading is immediately transferred down through the material to the base. In a normal situations, calculations give us a 3 to 4 times the loading capability in that 8 inches of the tires. You can see behind us, the tires are being laid directly onto the material. They'll be filled in with gravel. That then creates the base material we're talking about. They'll overlay it with a couple of inches on top and then a surface treatment, and the road is done. So you have a significant initial construction cost savings. We're looking at a minimum of 18%. You've got, again, as you see behind, no need for water, which typically is factored in at about 30 gallons per cubic yard of base material. No compaction testing's required because this material is, quote, compacted the minute it's installed. And then from a community perspective, this gives us an opportunity to reuse all of the old tires that we all see scattered around the countryside as we drive around Texas. To give you an order of magnitude, a 12-foot wide, 1-mile lane road with this type of construction will use 12,000 of these tires. So a classic example of somebody's lemon being made into lemonade. The old tires we're trying to find a use for, we now think we might have found a very useful use for those tires.
We look at this as a solution that we think is going to be a game changer for South Texas counties. It's a whole new change in process on how they repair roads, and we think this is what counties are looking for now that there's been an increase in road damage due to the oil production activity in South Texas. And for AACOG, it's really providing a regional solution to regional problems.
How's it going to get out?
When you dress up the action.
We'll wait till these guys unload. Good morning, everybody. Morning. Is this not a glorious day or what? If you don't know where you are, you're in Guadalupe County on Elm Creek Road. And thank you for being here. My name is Joe Ramos. I'm Senior Director of Regional Services for the Alamo Area Council of Governments. With me today is Jeff Labenz Huff, and anybody with three names, you gotta be leery of them. But he's with HDR Engineering. And then we also have Sam, Sam, where are you?
Right up front.
Oh, Sam, I'm sorry. I was gonna tell you to stand up. Sam Bassano. Sam is the inventor of mechanical concrete, the process that you're gonna hear about today. And he's also the patent holder. And he's from West Virginia. So welcome, Sam, to South Texas. All right, so let's get started. Again, I'm Joe Ramos with the Alamo Area Council of Government. This morning, you're going to see a process that's called mechanical concrete. And we think that this is a new process that's going to help Texas counties deal with the issue they've been facing on severely damaged roads due to the increased truck traffic and the increased heavy load truck traffic in South Texas. We have a statement that says, meeting regional challenges with regional strength. We thought that the road damage issue was a regional challenge that all of us were facing, so we wanted to come up with a solution for that. Jeff and I met about 10 months ago. We were both involved representing our respective agencies with the Eagle Ford Shale Consortium. If you're not aware of what the Eagle Ford Shale Consortium is, it's a group of organizations, of elected officials, of individuals that belong to the 26 counties that cover the Eagle Ford Shale. They've been meeting periodically for the last 2 years. Jeff was the chair of the infrastructure committee. I was a member of that infrastructure committee. After one particular meeting in Uvalde County, we had a discussion about what was taking place, and we said we need to do some research and see what we can find to help counties deal with the road damage problem. So his engineering firm, his company, went out and did some research, and he came across Sam's mechanical concrete process. Last October, Jeff and I traveled to West Virginia, met with Sam, and he gave us a tour of some of the county roads in West Virginia. Now, West Virginia, unlike Texas, their Department of Transportation repairs all county and state roads. But he showed us roads of different grade levels where they had used the process, and it was working fantastic. It eliminated a lot of their problems. So Jeff and I thought, what a great idea. We think we can come back and sell it to Texas, and it's taken us 10 months to get to this point. Because when you describe the process, it sounds so simple that people don't think it's going to work. And that really is the magic of the process, is the simplicity. And you'll be hearing that word throughout the other presentations. It's simple, it's cost savings, and it endures the heavy truck traffic that these roads encounter. So this morning, I'm going to invite Jeff to come up and talk a little bit from an engineering perspective of the beauty of this process. And then later on, I'll come back out and close the program. So Jeff, it's all yours.
Good morning. You mentioned the Middle Rio Grande Consortium that I'm a part of, and it probably represents and has touched probably every one of you from a city or a county perspective. Leodoro Martinez was going to come. I don't think he has made it, but I want to make sure that that organization gets the appropriate accolades here for being the ones that kind of brought this whole thing to our attention, which led to working with Sam to get us to this point. I've got a couple of boards that I want to talk you through and some information. When I finish, Sam will come up and talk about the experience in West Virginia and the technical aspect of why it does what it does. You can see in the 4 photos here, and you can see it out here. This is the progression of how this system works. The issue and the secret of mechanical concrete is above the base, the subbase, and whatever material you want to put on top. Those two parts of the section are exactly the same. The mechanical concrete is the part in the middle that makes this so special. If you look at typical loading, typical design sections, for the kind of truck loading that we're experiencing in South Texas, heavy truck traffic requiring typically 18, 20, 22, 24 inches of a built-up section. So initially you can see the material that you got to buy for that kind of system versus mechanical concrete. You can see the delta immediately. Then you start looking at the construction activities. If you're going to put in 20 or 22 inches of material, you first got to dig a hole 20 or 22 inches to put it in, and then you've got to get rid of what you just dug out. Those of you, and most of you, I think, are familiar with the process. If you need a 20-inch section when you're done, you don't just buy 20 inches worth, bring it out, dump it in, and start paving. You got to build up that 20 inches in layers, in lifts, like a cake. So you're bringing in 8, and you're compacting it to 6, then you're watering. And then you bring in another 8, water and compact. And you build it up. All of that takes time, takes money, takes equipment to get to that final stage. Mechanical concrete, you come in, you dump it in, you walk away, you are done. I mentioned the water issue. Ran some calculations, talked to some contractors to look at what is the metric that they use when they price your work for the water they're going to need to build up all of those sections. About 30 gallons per cubic yard is what they're going to price, and they're going to charge you to build it. Doesn't sound like a lot of water until you start looking at volumes. What I did here, just as an example, 20-inch section, 12-foot wide section, mile long. Just the water, 117,000 gallons of water. You put a typical road, which is not 12 inches wide, it's 24, you're looking at over 200,000 gallons of water you're buying that's going into the ground. Now, the last 3 or 4 days around here, our sensitivity to water has kind of taken a hiatus. But we all know we might not see another drop till late September when Alabama gets its ass kicked in College Station. So there's a community environmental side. The only water that you need here is those bottles in that cooler back there for the guys building it. The rest of the construction doesn't need any of that water. So there's a cost savings and there's an environmental sensitivity savings to that. Not to mention, on top of everything, the tires where we use it. These are not special tires. These are just everyday tires that we see, unfortunately, everywhere. We've all heard, and we've probably all told people, this life lessons of life gives you lemons, go make lemonade. Well, South Texas, all of Texas, has been sitting on piles of lemons that are growing while we're sitting here. We think we got a recipe for lemonade that tastes pretty good. And if you've got any interest in this afterward, pick up my card and we'll come talk to you about how we make this lemonade and get rid of some of these lemons. And Tim, where's Tim? Man in the green shirt has told me on 2 occasions, and today, he will never be the long pole in the tent of building this system anywhere around. However many tires we need, Tim will get us the tires.
What's the cost?
The tires, about $1 a piece, and possibly a nickel a piece to transport them depending on where your project is and where Tim's tires are.
How many tires in a mile?
How many tires in a mile?
12,000.
12,000 for a 12-foot line.
12 foot.
12-foot wide lane, 1 mile long.
So you double that for a 24-foot wide section. This system is ideally suited for the heavy truck traffic. And that's what we saw out in West Virginia. But there's several municipalities here. You're not going to get that constant 18-wheeler traffic. Some of you, Dilly, probably get some of that. I know Carrizo Springs gets a lot of that through the downtown. But this provides actually more strength than you need. But to give you an idea of cost savings, we did talk with Pearsall earlier this year. They had about a 1,000-foot stretch of city road that they wanted us to look at for this system. So we had them send us the typical section. You're going to go rebuild this road like you normally will. Send us that section. What are you going to do? We got that section, we got it to Sun, and we told them price out 1,000 foot of this section, and then price out 1,000 foot of mechanical concrete. The cost difference, initial cost difference, about 8%, but twice as fast. You can see from here, you can actually build this road from both directions at the same time. Now in the end, even if you do that, you're going to use the same amount of material, a little more labor, but you're cutting the time down. And those of you involved in construction who've had construction companies understand that that general conditions component of a contractor's bid is very much determined by how long is it going to take me to build whatever it is I'm building. So when someone says time is money, a lot of businesses, industries use that phrase. Well, in construction, time is money. If they can build it in 2 months instead of 4, there's real money they're not going to spend that gets reflected back in the bids they're giving you to build it. So that speed also factors into this cost. But when the price came in 8% low, I then told Sud, go back, what would this section be if it was a mile long? Again, construction time, almost half. The cost savings was 18% at the mile length, when that economy of scale really starts to kick in. So even those of you who have control and responsibility for city-type streets, there's significant cost savings that this system can bring to you. We think this, as Joe has said, is that game changer type of application. But to take it to an extreme, is there anybody here from the oil and gas industry? Back there, somewhere back in the back. I said this system really starts to shine when you start to load it up. That's a picture of the transload facility right outside of Morgantown where Sam lives. Coal trucks like what you see bring coal down to this facility. Any golfers in the group, a well-hit 8-iron from one of those truck lots will put your ball in the Monongahela River. Take the coal off the trucks, put it on a barge, take it away. 800,000 pound trucks. 80,000. 300 to 400 of those travel that road every single day.
It's a gravel-based road.
It's built just like this, a little thicker. The contractor who's responsible for upkeeping that road has kept records and is telling us pre-mechanical concrete, post-mechanical concrete. Anybody remember the old commercials about the Maytag repairman sitting around with nothing to do because they never break? Well, that's kind of where Jack is now, because his cost, pre-mechanical concrete, post-mechanical concrete, have dropped 70% with this system. And that's just the gravel system. And in many cases, oil and gas companies, oil roads, pad sites, that's all they need. But that's the kind of savings and long-term maintenance costs that this system can bring. And Sam has got actual applications there. Joe mentioned that we went over there. If any of you would like to go over, pardon the pun, but kick the tires and see these installations in person, let me know. And we can resurrect that 2-day trip and take you over there and see that situation, see a concrete application, and see the asphalt right through a neighborhood. Just recently, and there's a testimonial written here, the city of Westover City now is starting to use this system on their road repairs. I want to turn it over now to Sam, first generation Italian from South Italy by way of Morgantown. He will probably forget, so I'm going to tell you now. Civil engineer by trade, former head of the West Virginia Department of Transportation, former administrator in George Bush's Transportation Department, and the inventor of this system. He can talk about the design expertise, why it does what it does, and some of the value that he has seen and his communities have seen over in West Virginia. When we're done, there's going to be a slight minor demonstration here for you. And again, we will stay around. The information here, please take, and we will answer any of your questions at that point. Thank you. Sam?
Thank you, Jeff. After 30 years of being a consulting engineer, I got the reputation of being one of those hairy-eared engineers. You know what those are. So when the governor asked me to be head of the transportation department, I decided I would sell out my engineering business and do that, and I did. And while I was there, the legislature gave responsibility to the highway department for getting rid of a bunch of scrap tires. I had 2 piles. There were public health problems. So I asked the engineer, so why can't you just bury those in the base of the road? Why can't we just bury them? They said, well, there's 2 problems. You can't bury a tire because you can't fill it up completely with anything but air. You can't get the stone in it, and it'll leave soft spots in the base of the road. And he said the other problem is they hold water, and that causes another problem. So I spent the next 5 years trying to figure out how to solve those 2 problems. One night I was out walking after dinner, and I had the brilliant idea, if I cut the sidewalls off the tire, I could solve those 2 problems. Well, when I saw what I saw, I'm being a civil engineer, I said, this is not just about burying tires, this can hold that stone together. So I started doing some research on it, and I found out that nobody had done this before. And next thing you know, I quit government and started developing this idea. And that was all started 2004, 2005. 2006, we built our first road for the West Virginia Division of Highways, only about 400 feet long, but it's a little dirt road out in the country that floods 4 times a year. Now, that's down at the foot of a hill in one of these hollows, a little stream off the side that overflows and floods this road. Well, they'd always have to rebuild the whole road every time it would flood because it would wash out the base, wash out the ditches, wash out everything. Well, after the first flood, the county administrator called me up and said, well, we had a flood. And I said, what did it take you to get it back into service? He says, nothing much. We just had to tailgate some material on top of it again. So he told me after 2 years he had reduced his maintenance costs on that road 75% because of the flooding. Mainly because he didn't have to rebuild the base or any of the ditches. So that sort of got us off to a good start. After that, we got into the coal haul road business, which is a big problem in West Virginia, particularly on the secondary roads. And as Jeff told you, we've got roads there with concrete, asphalt, and stone bases. This is a stone-based road, this picture, that where we know the reduction of maintenance costs on that road because of the mining company. And so we've had over 1.5 million coal trucks run across this stuff in the last 2 years. So in these 4 or 5 different installations that we have. So we know it works and we know it'll hold up. So I'm happy to be here with you. I appreciate your public service because I did a little bit of it myself. I really appreciate all of you willing to take a look at a new idea like this. And this problem with tires is a big problem. There's 1 tire generated per person per year in the United States. That's 300 million tires. Now that means there's 30 million of them generated. 30 million or so are generated in Texas. And 60% of those tires are burned as fuel. That still leaves 40%, which need to be recycled. Now, we can't compete with the fuel burning, but we can certainly help them recycle them. And what we found out when we did the original testing on this, that we could easily put that stone in there and get it to support 200 pounds per square inch. Now, you all know that a semi-truck tire has 100 pounds per square inch in it. So we're easily supporting twice the load of that semi-tire. Because being an engineer, I wanted a design factor of at least 2. Well, that tire gets about 10 or 12 pounds per square inch on it when it's got 100 pounds load on it, 100 psi load on it. Now, you know what the tire is designed for, 44 pounds. So it's virtually indestructible when it gets into this location. It's far stronger than anything a civil engineer would ever design to do something like this. And that's just an accident because the tire is a pretty amazing piece of manufactured equipment. So we have something extremely strong, very inexpensive. Total cost of it runs about $2 to get one of these in place. But you see, by eliminating the compaction requirement, eliminating the water, and you effectively get about a 24-inch base out of this material. So about 8 inches of material gives you the working ability of about 24 inches of stone base. So basically that's what you're getting. And
What's the depth?
any questions? What's the depth?
Well, I mean, say you're going to do asphalt, you're talking about hot mix, right?
Right. Well, hot mix. This is going to get chip seal.
You're going to get a chip seal on.
Yeah.
What's the cover of road material on top of that then?
Well, they'll probably put 2 to 4 inches of tailgated material compacted on this, and then put the chip seal on there.
Put the chip seal on that.
Right. See, we don't recommend you putting anything on top of this unless you do concrete. If you do concrete, you can put it right on top of it. But if you're going to do hot mix or chip seal, you need to put a little asphalt base course on top of that before you put the material on. But and if you're going to do a unpaved section, 4 inches is all you need.
And you don't need, do you have a compaction for that 2 inches or 4 inches?
Standard
95?
Yeah, 95%. What you'd normally do if you were going to put an asphalt surface in. In other words, we're not, the only part of this that changes your construction process is the mechanical concrete itself. The base has got to be prepared like you normally prepared. The mechanical concrete up has got to be done like you normally do it. Got to be done according to your standards and specs. Yes, sir.
If you tore up the road, can you reuse the tires from the previous road somewhere else?
Yes, sir. Completely recyclable. You can come in here with a dozer and doze this whole thing up and take it somewhere else and use it. Use the material too, not just the tire.
If you, in my situation, I'm from Karnes County, and our traffic down there is such it's virtually impossible to close a road like this.
Yep.
If we did half the section, if we closed half the road, how would you recommend you contain your work area until you do your other half?
Well, your usual traffic control you're going to have to maintain, but you can definitely do that. We've done that we had to do it with one of these coal haul roads at a power plant. Got 600 trucks a day on it. We had to keep the truck traffic going. So
Right.
you can take half of it out, maintain your traffic with your usual traffic control system. You have to go one way.
Right, I understand that. My question is, if you open up half the road, you excavate half the road,
Right.
and you lay your tires in and you lay your material on it, and you get that half completed where you can move the traffic on it.
Okay.
And then you excavate the other half.
Right.
When you do that, so that you don't have a breakdown between the two pieces of construction, what do you recommend to make that a continuous piece of construction?
Those tires will stand straight up. You don't have to do anything. You can run right, because they can run 90 degrees right beside it.
Okay.
So you can run right on top of them with right at all the way to the edge.
If you go on to YouTube and type in mechanical concrete, there will be several listings there, but you'll see a couple of videos, one of which is exactly what you're talking about. Someone standing on this side of the road, this they have excavated, that half they have built, and you can see the tires of the trucks running across that portion while they're building this portion. That's all that little minute and a half video is someone standing here watching exactly what you're talking about going on. Don't have to be. Don't have to be. The tires, they don't have to be lined up. That kind of geometry, you don't have to worry about. And you can see when you go out there, as Sam says, round to the eye, drop them down. You don't have to make nice, clean lines.
That's our.
Don't need to do that.
They don't have to be in a grid. They don't have to be in a perfect grid. You know what I mean? They just need to be laid out and filled in the area, because their tires are of different sizes, different diameters, so you need to be flexible as far as trying to put them in. Now, you'll see that some of these tires right out here close are not round, but it's still okay because these guys, it's their first time doing it. And after I talked to them about it, they understood what we were dealing with when we went round to the eye. It still has the ability to confine the material. What this is the astonishing power of confinement. When you lay that cylinder down and put stone into it, it instantly solidifies. It actually goes through a solidification, because it will not go anywhere once it's confined. It's almost the same thing. It's why we call it concrete. It's almost the same thing as what happens when the concrete cures, holds everything together. And you know when concrete fails, it splits, it doesn't crush. So this is what it does. This keeps this material from going sideways. It instantly solidifies it.
I don't want to dominate all the questions,
go ahead.
But another question, because of availability of local material, we don't have access to 57 rock or clean stone. If we use normal 1.5 to 2 inch base with fines in it, will it work just as well?
Sure, well, you just need a little compaction with it, that's all. The reason we specify 57s is you don't need any compaction with it.
Right.
If you use normal material, you can put it in there and give it a little compaction, it'll be fine. And it doesn't need as much compaction. You don't need to push for an optimization on that. Because once you get it confined and get it solidified, it's in there. We've tested sand, number 8s, number 57s, and general crusher run. We were able to get 200 pounds per square inch out of all of them, out of sand. So you could stabilize any granular material out of this if you want to.
Do you have any installations like this on expansive clays?
Well, we have some on clays in West Virginia now. They're not expansive. They're basically just soft Appalachian clay material. Now, we feel that it will work on these clays because what it will allow them to do is not go through these cycles of being dry and getting wet and so on and expanding. We can maintain them in a certain constant condition. And even if it does expand, you're going to get a general movement. You're not going to lose the strength of the material. And we recommend, if you work it on clay or soft subgrades, that you put separation fabric in. Keep you from losing the stone material.
Is that figured into that 8% and 18% cost factor?
The 18% was at a mile based off of the city of Pearsall's traditional street replacement.
There's no fabric in that.
There was no fabric.
No.
No fabric in there.
Typically, the alignment puts the tires on, the last half portion of a tire on the outside. But if you also look at those videos at Mechanical Concrete, you will see one where there's a piece of equipment that literally is on the edge of the last tire on the edge of the road, driving across it. So there's a tremendous amount of fluff in this design. The exactness of so much of construction doesn't apply to this.
Where you got 3 feet on the edge of the road. You can put the row of 2 of these cylinders down there, take that material up, put the same material back in, repave it, and it'll solve that problem. Because it will not collapse laterally. Water won't affect it. Water won't cause it to lose its strength. And if you got wrap, you can use wrap in here. You can use any kind of granular material.
In fact, the water will drain through, won't it?
Yes, it will. Particularly if you got anything, you got, it's great. It's like 57 or wrap, something like that. So go right through it.
Help it out.
That's another reason we specified 57s is because you give you complete drainage. Yeah. And water's a big problem in our part of the world.
Any special procedures for cutting it open?
We don't have any.
Water line repair, wastewater line repair, any type of subsoil repair?
Well, that's a good question. No special procedures. You're going to saw cut the top off probably. Then you can bring this stuff up with a backhoe, set it aside, and put it right back in. Lay it aside, put it right back in. And one of the things that you'll get with this is you won't get ultimate sag that you get. You'll be able to get a compacted base again.
Same.
Which is what the utilities can never get to.
Amen.
You can tell them to just fill the trench up to 57 if you want. Where they do the repair, you know, they do the whole thing, and you got it.
Sir, you have thought outside the box.
Well, I lucked out.
This is
It's that hairy-haired engineer, you know.
He's still waiting to make his first million, though, right?
that's all. Let's hope he makes 5 million.
Well, thank you very much. Appreciate your attention. You know, they talk about game changers and so on. What I think this does is empower people to build roads without all the heavy technology that you've always needed. For example, your crews now, your county crews can now go out and build an industrial grade road with very limited equipment and resources. You don't need all the technology to do that, and that's pretty good. That's what I'm glad about.
Now this process is patent,
Yes, sir. I'm the patent holder.
so we shouldn't go out and start ordering tires.
Well, not yet anyway, but there's a nice.
We can talk to you. We can talk to you afterwards. We'll fill in the details a bit later.
There's a special offer for anybody that wants to use it on our website, that you can get it. You can do it at a very low rate. That you want to try it out and see how it works. I'm more than happy to work with you. Yes, sir.
These tires you show on their car and truck tires, does it work the same if you had a manufacturer cutting or someone cutting 18-wheelers?
Well, 18-wheelers are 12 inches wide, mostly, or bigger, 12 inches bigger than 12.
Right.
And they have steel in the sidewalls. So they're much harder to cut the sidewalls out.
Right.
You need a really special piece of equipment, which is much more expensive than the one we use to cut these out. But it will work then. What we've used truck tires for is retaining walls, mechanically stable earth retaining walls, because they're more consistent in their width and diameter. We made retaining walls out of them. So if you're pretty flat country, but if you've got places where you got slips or things like that, they'll work very well for that. Or you can use SUV or light truck tires and get the same effect. 36-inch diameter.
Sam, how tall is that wall you built?
15 foot.
For that question, sir, we make truck tire truck tire treads as well, and we have that special equipment that he's talking about. So it's available. It's available to you. 20,000 standing by for you. I'll deliver them today.
After you talk to Sam.
After you speak with Sam offline.
We recycle our tires.
What kind of thing of usage were you thinking about with the truck?
No, it's just, I'm the chairman for AACOG and resource recovery, and that's one of our biggest problems in Texas is tires.
Yeah.
And we've got a lot of people in the 11 and 12 counties of AACOG that I serve on utilizing tires. Coming from Comal, where I am, we recycle them 100% using them through C-Mix as a fuel.
Okay.
But
Right.
the problem is anybody getting rid of 18-wheeler tires.
Oh,
So
yeah.
that's why I was
It's a
asking.
big problem.
We get calls all the time on, hey, can we drop them off? We don't take them.
And even as the representative in the AACOG, it's just a hard thing, and we've been working on that for the last 12, 13 years.
Well, they make great retaining walls. We've got 15-foot high and mechanically stabilized retaining wall using those tires.
Fantastic.
And it reduced the cost on that retaining wall by 50%.
Wow. Really?
And it will reduce. You can use them in place of gabions and reduce the cost by 50%. Use a truck tire, semi-truck tire.
Maybe talk to TCEQ and put a bug in their ear. That might be really.
That's the best use of that truck tire. Is retaining wall or
Do you
gabion.
have a video showing that also?
The construction of
Yes,
the
the retaining wall.
well, we don't have any. I don't have any construction videos of the retaining wall, but I have pictures of it. How it was built. It was built just like a traditional MSE wall. You know what an MSE wall is? Well, all we did was overlay the grid material in between the interface of the tire, and that was it. Now, what we recommend now, because nobody thinks tires are pretty but me.
And Tim over there.
What we recommend now is you batter them back 1 to 6. Let the grid material come out, and then broadcast topsoil on them, seed them. It'll disappear in about a year. They'll grow. They'll cover in. They'll grow right in.
So you really didn't know what's.
You won't even know. You'll have You have a retaining wall that completely eliminates lateral pressure. No, lateral pressure. Water pressure, active soil. Because the water can't stand in there, it just goes right through it.
If anybody has any questions about an application, wanting a picture, pick up one of my cards, send me an email. Have you got a picture of this kind of application? And I'll scurry our library of stuff and send you anything that we've got that represents what you think you were asking about.
Now we're ready to do a demonstration here for you guys and show you how this works and show you the guys doing it. And any questions that you have you want to ask me, I'll be around for the rest of that day. Thank you very much.
Thank you.